another melted RTX 5090 Founders Edition, and it got both connectors, this time GPU and PSU, and Asus Lockers FXL, and the cable itself. This happened to a German user who sent the card, the PSU and the connecting cable to Der Bauer, a German overclocker, for analysis. I watched the video after a friend sent me the link, and I have some notes about it. Besides showing the failed GPU, PSU and the melt cable, the German reviewer found that his PSU, a Corsair AX1600i, delivered 22 to 23 amps onto one of the 6 12-volt gauges on the 12-volt 2x6 connector, carrying the majority of load to the RTX 5090 FE under full load, around 600 watt total power or 50 amps in total. Such a high amperage is insane, and it makes me wonder how the long gauge of the AX1600i managed to withstand it, since it is not rated for so high. Typically, AWG16 is at 10 to 14 amps maximum, depending on the wire's length and, of course, the operating conditions. Even the pins on the connector are not made for such high amperage and will melt in a very short period, so I am not sure that the clamp that he used was measuring correctly the amperage. If indeed the RTX 5090 FE has so high power consumption on a single wire of its connector, then most of them should be dead already. I'm not telling that everything is good here, but the whole thing looks weird to me. Unfortunately, NVIDIA didn't find me worthy of getting an FE card, so I cannot check whether its power delivery system is proper or there is an issue there. Another note, it may seem like current takes the shortest path. It is more accurate to say that it flows through paths based on their resistance, with lower resistance paths, which often happen to be, the shorter, carrying more current. The problem in 12-volt 2x6 cables is that you have not 2 or 3, but 6 gauges carrying current which are close to each other. So the combined heat of them can easily melt the cable insulation if anything goes wrong. The same applies, of course, to the 12-volt 2x6 headers. In any case, the whole design of the RTX 5090 FE is weird, with the connector being angled and with its leads not having the same length all. The best approach for this specific broken GPU would be to tear it down and check with proper equipment the resistance of each pin up to the corresponding regulating circuit to find out if there is a path with a way lower resistance where current flow is increased. Another thing I want to state here is that using IR cameras to measure temperatures on connectors and cables is not the best approach. It is way more preferable and accurate to attach thermal probes to have temperature readings. If I manage to get my hands on an RTX 5090 FE, I will cut the cables of the PSU, install shunt resistors in between, and check amperage on each one of them under different scenarios to find out what is going on. But I'm sure that increased amperage, or even close to what the German reviewer measured, is not the case for most RTX 5090 FE, else none will survive. That's all, guys. Bye bye.